Guys, we'll continue with exercise 9B question number 21. Exercise 9B question number 21. Okay. A plus bi is equal to x plus I the whole square upon 2x square plus 1. Okay. And we need to prove a square plus b square is equal to x plus 1 the whole square, x square plus 1 the whole square upon 2x square plus 1 the whole square. Okay. Now see, if you take the modulus of this, it is going to be a square plus b square. So my intention is to take modulus on both the sides. Okay. We'll take modulus on both the sides and solve. Now for that reason, first I will try to simplify the right hand side over here. This part I will try and simplify. So a plus bi equal to x plus I the whole square upon 2x square plus 1. Okay. Now see, right hand side I'm simplifying x square plus I square plus 2xi upon x square plus 1, 2x square plus 1. So this is x square minus 1 plus 2xi upon 2x square plus 1. This is a plus bi. Now I'll take modulus on both the sides. I'll take modulus on both the sides. Right hand, left hand side, it will be root of a square plus b square. Modulus of a plus bi. Left hand side, the modulus will be given to both numerator and denominator because modulus of z1 upon z2 is equal to modulus of z1 upon modulus of z2. So x square minus 1 the whole square plus 2x the whole square. Oh, sorry, I'll just do this thing in the next step. I'll just write down this entire term in the modulus first. X square minus 1. 1 second. X square minus 1 plus 2xi. And down it is 2x square plus 1 plus 0i. Okay. So root of a square plus b square is equal to root of real part square plus imaginary part square upon root of real part square plus imaginary part square. Okay. Now squaring both the sides, all the roots will get eliminated. So this will be a square plus b square upon 2x square plus 1 the whole square. Okay. And this is going to be x square the whole square minus 2x square plus 1 plus 4x square. Now plus 4x square minus 2x square will be plus 2x square. So a square plus b square is equal to x square the whole square plus 2x square plus 1. Now that 1 square I had written 1. Okay, so I'll just keep it as 1 square. Okay. Right. So this is 1 square upon 2x square plus 1 the whole square. Now if you take a look at the numerator, it is expansion of x square plus 1 the whole square. Okay. So if you expand this, you'll get the numerator entire part. Hence proved. This is what was supposed to be proved in first place. So this is how we have completed this particular problem. Let us go to question number 12. Question number 12, Z1 and Z2 are given. First part, they are asking real part of Z1 into Z2 upon conjugate of Z1. Okay, real part of this. So first I'll calculate Z1 upon Z2 upon conjugate of Z1. So Z1 is 2 minus I, Z2 is minus 2 plus I, and down it is conjugate of Z1. So it is 2 plus I. So how to go ahead with this? We have to multiply these two brackets. We have to simplify that upon 2 plus I. Okay. After multiplication, you'll get certain value that will be divided by 2 plus I. Now we have a proper format of a complex number in the denominator. So this you will multiply and divide with the conjugate of the denominator. Okay, that's how you'll get the value of z1 into z2 upon modulus of z1. Write it in the format of a plus bi. Okay, and they are just asking you what is a. That is a real part. I hope everybody got the entire solution. Okay, I'm not solving entirely, but then just giving you the hint. Second one is imaginary part of 1 upon z1 into z2 conjugate. So first I'm going to calculate 1 upon z1 into z2 conjugate. Z1 is equal to 2 minus I modulus of z2, that is minus 2 I. Okay, so this will be 2 into minus 2 minus I into minus 2 minus I. Just simplify this. Minus 4 minus 2I plus 2I plus I square. So plus 2I minus 2I is gone. I square is minus 1. So this will be minus 4 and this is minus 1. So the answer of this is 1 upon minus 5. Okay. Now 1 upon minus 5 is minus 1 upon 5 plus 0I. So what is the imaginary part? Imaginary part is 0 over here. Imaginary part is 0. Okay, that was what asked in the problem. Let us go to question number 23. Okay. So the left hand side is z1 upon z2, the whole conjugate. Okay, so what is z1? Z1 is 3 plus 5, 5i upon 2 minus 3i. So the conjugate of this entire division. So 3 plus 5i, 2 minus 3i, multiply and divide with the conjugate of the denominator. 2 plus 3i, 2 plus 3i. Now once you solve and simplify this, you'll get a certain complex number in the box bracket. I'm not solving this, but then solve this box bracket very clearly and some answer you will get. Some answer you will get in the form of a plus bi. Take the conjugate of it. Take the conjugate of it. This is the LHS. Now RHS is equal to Z1 bar upon Z2 bar. So Z1 bar is equal to minus 2 plus, sorry, uh, 3 minus 5i upon 2 plus 3i. So this you solve, multiply and divide with the conjugate of the denominator. Simplify this and try to prove LHS equal to RHS. Okay. Next problem. Question number 24. So given the value of x is minus 2 minus root 3i, something like this. Okay. And you are supposed to find out the value of 2x raised to 4 plus 5x cube plus 7x square minus x plus 41. This value you are supposed to find out. Now, if you put the value of x individually over here, it will be very long and tedious for us to calculate. So understand the procedure for this kind of problems. So x is equal to minus 2 minus root 3i. Now first we'll separate the real and imaginary part. The real terms on one side, imaginary terms on one side. Since so this is separation. And after separation, you have to square both the sides. Minus root 3i the whole square. So x square plus 4x plus 4 is equal to 3i square. X square plus 4x plus 4 equal to minus 3. So x square plus 4x plus 7 equal to 0. Okay, equation number 1. Equation number. So this is what we got, x square plus 4x plus 7 equal to 0. Now this part, left hand side, you make it as a divisor. So you make it as a divisor. So divisor is equal to the left hand side, which we got over here, x square plus 4x plus 7. Now this is long division method. X square into what will give you 2x raised to 4? It will be 2x square. So this will be 2x raised to 4 plus, multiply this with this both terms, 8x cube plus 14x square. So this is minus, and this is also minus. So this is gone. Plus 5 minus this is 8 is minus 3, minus 3x square, minus 7x square, minus x plus 41. Now x square into what will give you minus 3x square? So it will be minus 3. So minus 3x square. Okay. I think so. This should be cube. Sorry. Okay. Minus 3x cube. So let me make that change. X square into what will give you minus 3x cube? So it is going to be minus 3x, because minus 3x into x square is minus 3x square. Okay. Minus 12x square minus 21x. So subtract this, there will be sign change. Okay, and then finally this will be 12 minus 5, that is 5x square plus 20x plus 41. Now x square into plus 5 is plus 5x square. Okay, plus 20x plus 20 plus 35, sorry, plus 35. 5 into 7 will give you 35. So minus, minus and minus. So the remainder will be 6. The remainder will be 6. Now one thing you are supposed to write, dividend is equal to divisor into quotient plus remainder. So dividend, as I can see, as you all know from the question, it is the thing that we are supposed to find out, the value of 2x raised to 4 plus 5x cube plus 7x square minus x plus 41 equal to divisor. Divisor we had taken it as x square plus 4x plus 7. Quotient, if you take a look at the long division, this is the quotient, 2x square minus 3x plus 5. And remainder is 6. See, we have done in the long division method, remainder is 6. Okay. Yeah. Now this value is equal to 0, which we have already written in the first slide. Why this value is 0? Okay. So see, divisor is 0. So this will be 0 into this entire bracket, that is 0 plus 6, which is equal to 6. So the answer of this is 6. Okay. I hope you understood the problem. Similarly, the next problem also, I'll just give you the hint. Question number 25. Z is equal to minus 3 plus root of minus 2. So Z plus 3 is equal to root of minus 2. Separation of real and imaginary part. Now, why this is imaginary part or a complex part? Because there is minus sign within the root. Okay. So first part is separation, then squaring both the sides. So Z square plus 6Z plus 9 is equal to minus 2. Root and square will get cancelled on the right hand side. So Z square plus 6Z plus 11 equal to 0. Equation number 1. Now make this term as the divisor. We are supposed to find out the value of Z raised to 4 plus 5Z square, 5Z cube plus 8Z square plus 7Z plus 4. Make this term as the dividend and do long division method as per the, as I have taught you in the previous problem. Okay, fine. Okay, so that is how you have to do long division method and complete the entire problem. Okay, so that is the end of exercise. Thank you.